Hello, my name is Casey Gibler, and I'm doing a reassessment for the, let's see, which one? The Properties and Materials Standard, Chapter 14. The question I've chosen is problem 60. It says, a very thin spherical plastic shell of radius 15 centimeters carries uniformly distributed negative charge of -8 nanocoulombs on its outer surface. So it makes an electric field as though all the charge were concentrated at the center of the sphere. An uncharged solid metal block is placed nearby. The block is 10 centimeters thick and it's 10 centimeters away from the surface of the sphere. Sketch the approximate charge distribution on the neutral metal block. So this is what I did for the approximate charge distribution. Since all of the negative charge is surrounding the sphere, it's going to cause there to be a positive charge on the side of the block closest to the sphere and negative on the other side. This is due to the sphere giving off a net negative charge. The metal block will be polarized with the side closest to the sphere bearing a positive charge and farthest away bearing a negative charge. Well, then we move on to part B, which says draw the electric field vector at the center of the metal block that is due solely to the charge distribution I just sketched. So that's including contributions of the sphere. Well, that's where I get to part B, and I have the the electric field going in that direction, mainly because the electric field is going to flow from the positive end to the negative end, because a positive charge is going to have the charges going out all the way around, and the negative charges are going to have it going in all the way around. So therefore it'll go that way. Alrighty, and then we move on to part C. This is calculate the magnitude of the electric field vector you drew. Explain briefly and make any approximations of what they are. So basically they're asking what is the electric field due to the charge buildup inside of the block. So first what I'm going to do is I'm going to solve for my R, which I have to be 0.300 meters. How did I get 0.3? Well, as you can see, I am trying to go from the center of the sphere to the center of the rectangle, so I have 15 plus 10 plus 5 gives me 0.3 meters, converting from centimeters. So after that, I get my R value, or R hat, which is the vector over the magnitude. 0.3 divided by 0.3 is 1 meter. And then I was given the charge, which is -8 times 10 to the -9 coulombs. I have my magnitude just solve for. My 1/4 pi epsilon naught is equal to 9 times 10 to the 9th newtons times meter squared over coulomb squared. So then I go ahead and I plug in the values I just obtained, and I get -800 times -800 nanonewtons per coulomb. Alrighty. And however, we are looking for the electric field in the metal, which the E net at equilibrium in a metal, since it's a conductor, is technically 0. So the following should actually be observed. We just solved for the electric field from the sphere to the metal, what it's doing to the metal. So if E net's 0 and that's the electric field from the sphere, that means the electric field from the sphere and the dipole should add up to equal E net, which is 0. So 0 equals -800 nanonewtons per coulomb plus E dipole, and then I get the electric field of the dipole, and that gives me a +800. So that is actually the electric field. It's just the result of the charge accumulation on the surface where the dipole is. That concludes my video. Thank you. Oh, actually no, it doesn't. My glow script will not pull up on my computer right now because it's being dumb. So instead of using that, I chose to use Excel as my calculator because it is in fact an even problem, so there is no answer in the back of the book. So as you can see, I have my B1, which is my 1/4 pi epsilon naught, my B4, which is my R hat, and my B2, which is my R hat, and my B4, which is my charge, over my B3, which is my magnitude squared. And that gives me -800, which was the electric field that I had to solve for from the sphere onto the metal. So thank you very much.